Okay, more solving for theta. I know you're probably getting tired of this, but this is our last lesson on this. So here we go. First of all, on this particular one, you can factor out 4 sine out of this one. So I am going to factor out 4 sine. And when I do that, I will have sine squared plus sine plus 2. Okay? So, what I'm going to do is I'm going to deal with this first. So I have 4 sine theta equals 0. And if I divide by 4, I still get sine theta equals 0. And if you look at your unit circle, and I don't have it on here, but your sine value or your y value is 0 at 0 and at pi. So there's 2 spots that are answers right there. This inside part, you're going to see if it factors, and I bet you figured out right here. So this is sine and sine make sine squared. And then 2 is 1 and 2. Because it's positive right here, it either needs to be plus, plus, or minus, minus. And when you do that, there's no way you can get this positive sign right here in the middle. So that one doesn't factor, and when it does not factor, then you have to use the quadratic formula. So I'm going to just kind of clean this up a little bit here. When you use the quadratic formula, remember, the formula for that is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? Remember, your a comes from right here, so your a is 1. Your b comes from right here, so your b is 1. And your c is your constant, which is 2. All right, so the opposite of b, negative 1, plus or minus the square root of b squared, and 1 squared is 1, minus 4 times a is 1 times c is 2, all over 2 times 1. All right, then when I do this on the inside of the quadratic formula, it does not work because I have negative 1 plus or minus, and then I have 1 minus 8 in here, which of course gives me a negative number in here, and you can't have a negative underneath the radical, so that part is no solution, and the only solution then is to have 0 and pi. Okay, here's another one. We are going to see if this factors, so I'm going to factor this, and the only way to get 3 sine squared is to have 3 sine and sine. The only way to get 1 on the back is 1 and 1, and because it's plus at the end, it either needs to be plus, plus, or minus, minus, probably going to be minus, minus because of this. But when you do your outsides, you get negative 3. When you do your insides, you get negative 1 sine, and that only gives you negative 4 sine, not negative 5 sine. So this one does not factor. So again, we need to use the quadratic formula, and again, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. In this case, your a is 3, your b is negative 5, and your c is 1. Okay, so I am going to put that into the formula. Notice these have signs in the equation. So what I'm really going to do is I'm going to say sine at theta equals, and then I'm going to do the quadratic formula. So the opposite of b plus or minus the square root of b squared, so negative 5 squared is 25, minus 4 times a times c all over 2a. And again, I'm going to just simplify this a little bit. So I have 5 plus or minus the square root of 25 minus 12, and 25 minus 12 would be 13, all over 2 times 3, which is 6. Okay, now you don't need to simplify this anymore. What you need to do now is you need to go to your calculator. And this is asking you to figure out sine at some spot on the unit circle is that ugly, icky thing with a radical in it there. Okay? Obviously, you don't have coordinates for that. So what you're going to do on your calculator is you're going to do this. You're going to go, first of all, sine negative 1, and then you're going to put in 5 plus the square root of 13 over 6. Okay? And then you're going to go sine negative 1. And you're going to do 5 minus the square root of 13 over 6. Typically, one of these will work and one of these won't work. You're probably going to get an error on one of them, and you have to be really careful how you enter it into your calculator. So I'm going to show you this here. I'm going to make sure, first of all, my calculator is in degree mode, which it is. Okay. So I will go second sine, and then I'm going to put the numerator in parentheses. 5 plus the square root of 13. Close the square root, close the numerator, divided by 6. And I did get an error here, so I know that that one doesn't work. Okay, so that's that one. Now I'm going to clear that out, and I'm going to go 5 minus. So I'm going to go second sine, numerator in parentheses, 5 minus the square root of 13. Close my square root, close my numerator, divided by 6. And that gave me 13.44 degrees, okay? So if I'm thinking about this, this one doesn't work. This one, my calculator spits out 13.44 degrees, but remember there's usually two answers. So if you think about this, 13.44 degrees is right there. That's where my sine value is, that spot, but there's another spot over here where your sine value has that same number. And so this spot right here would be 180 minus 13.44, which gives you 166.56. Okay, so those are your two answers to that problem. Okay, this one I'm going to get you started on. This is kind of weird. You have sine times cosine in the same equation. Can't divide through by anything and get rid of one of those trig functions, so nothing is going to help you there. So on this one, what you want to do is you want to multiply both sides by 2, and that drops out, and now you're left with this. Okay. Still, this doesn't look real simple, but what you need to know is this. This is a double angle formula. It happens to be the formula for sine 2 theta. Okay, and now you're down to one trig function and you can do something with it. But it's not just plain old theta right here. There's that 2 in front, which means you need to go back to that 2 pi k stuff that we did earlier. So first of all, I'm going to look for this. Sine is negative 1 on your unit circle, down at the bottom at 3 pi over 2. Okay, so then I'm going to go 2 theta equals 3 pi over 2. This is sine, and sine's normal repeat is 2 pi, so I'm going to go 2 pi k. I will divide everything through by 2, and I will have theta equals 3 pi over 4 plus pi k. Okay, so my first answer is right here, which is 3 pi over 4. Then I'm going to add pi to that, and I'm going to make this be 4 pi over 4 so that I have common denominators. So 3 pi over 4 plus 4 pi over 4 would make 7 pi over 4. If I add another pi or another 4 pi over 4 with common denominators, the next one would be 11 pi over 4. And 11 pi over 4 is bigger than 2 pi. So that is not going to work because you only want answers between 0 and 2 pi. So these are your two answers for this problem. All right, and the last one right here. We are going to need to figure out what we can do to get rid of one of these trig functions. Right now, everything is on one side, and I can't factor anything out, so that's not going to help me. I can't separate them that way. So I am just simply going to add this 5 cosine to both sides. And then I will have this. Okay, still have two trig functions in here. I already had everything on one side and I couldn't factor it out, so really your only choice is to divide both sides through by something. I am going to divide both sides through by cosine. My cosines are going to drop. And then I will have sine over cosine, which is tangent. So now I'm down to one trig function, which is good. I will divide by 7 here. And I get tangent at theta is 5/7. Okay, If you look at your unit circle, there are no coordinates where tangent is 5/7. So you're going to go to your calculator and you're going to input inverse tangent of 5/7. Your calculator will spit out an answer, but remember you need to find its partner when you do that. So second tangent, 5/7 gives you 35.54 degrees. So 35.54 degrees. Okay, and if you think about your unit circle, here's 35.54 degrees right here. Tangent, remember, needs to get flipped first of all over the y, and that's 35.54, and then the x, and that's 35.54. But you need that last spot there measured from 0, so I need to go from here to here. So to get this spot, it's 35.54 degrees past 180. So I'm going to add 180 plus 35.54, which of course will give you 215.54 degrees. All right, and that should do it.